Yes, so students, we've already started with the chapter. We've already also learned the definitions which are important for us in metallurgy chapter. So we've already learned what is meant by a mineral, that which exists in the earth's crust. Then we also learned what is meant by an ore, right? Then I also taught you the basic definitions, but that is, one is your ganj and one is your slag, right? Now directly I'm going into the topic, depth of the topic. What am I doing? For every metal, right, basically for aluminium or iron, copper, silver, gold, I'll be giving the complete picture in every video. So this whole thing completes your iron extraction. When you're studying for your exam, one particular video, all the data will be there. And after that, after iron, suppose if I'm giving you aluminium, I'll give you the whole of aluminium, then again we'll go to copper, like that. So let us start with iron. So basically when I speak about iron metal, right, so iron, as I said, whenever we are trying to extract a metal, we are going to pick up the ores of that particular metal. Why? Because that is the easiest and economical way for extracting the metal. That is what we have studied. So first I'm going to pick up the ores of ores of iron. So what are the different ores? If I say the basic ore, hematite. Yeah, the first one, hematite. So in this hematite, your formula is Fe2O3. Then we have the next ore of iron, that is your magnetite. Magnetite, the formula is the higher oxidation state, Fe3O4. Right, now after that you have one more ore called siderite. Siderite, okay, siderite, that is your iron carbonate, FeCO3. You have one more ore which you are going to study, right? Iron pyrites, right? So simple FeS2. Now what are we going to do? Now from the earth's crust, we are going to pick up this ore of iron. This iron ore it undergoes different steps in the metallurgical processes. The first step is we are going to separate the ore from its ganj particles. So the first technique is you're going to take the ore. Yes, step 1. After that, step 2, you're going to take that ore and introduce that in a magnetic separator, right? So magnetic separator, basically there's a diagram also in your NCERT, no need of drawing any diagrams. So on the magnetic separator, you're going to pick up, suppose for example, if I take hematite or magnetite, I'm going to take that on the magnetic separator, and you have two rollers with an iron belt attached. So what happens whenever you're dropping this magnetic ore, either hematite or magnetite, that rolls or that moves on the rolls, right, on the rollers, that moves on that particular belt, and with whichever impurity or the ganj particle, right, as I said, ganj is an impurity. Now we are going to consider the magnetite or the hematite as the iron particle, that is the magnetic material, and the ganj we are considering as non-magnetic material. So with this concept, what do? As and when the ore along with the ganj moves on the iron belt, they get separated into two tanks. One is magnetic material tank and the non-magnetic material tank. Then, so what concept did they separate? We separated them based on their magnetic properties. That is the simplest one which you can read. So from that magnetic material, now I've got a tank with this particular ore where at least a part of ganj is separated, only a part. We are going to take that particular tank, and then we are going to take it for concentration, right? After separation, concentration. Now in concentration, what are we going to do? We are going to do different steps, the calcination, roasting, right? Smelting, all these. So basically calcination is something which you do in the absence of air. Roasting is in the presence of oxygen. Okay, we'll be doing different reactions also when I do zinc and all these, right? So now what happened? I'm going to take that ore, take it for concentration. So in concentration method, what is the first thing? Your iron oxide, whatever is there. Now let us erase this whole thing. Now your iron oxide, I said, from the magnetic separator belt, or this is magnetic separation, it has come for concentration. In concentration, I'm going to do a process called calcination. We call it as calcination here. Why? I'm going to take Fe2O3 dot XH2O, right? Some moles of water. When you're heating it, you're just heating it. I'm not saying in the presence of this one. When you're heating it, immediately this bond dissociates and you get Fe2O3 and plus XH2O. So this is done. The whatever moisture is there, that gets evaporated. Now we are left with this iron oxide. Now this is your main process. Now from the concentration process, we are taking it and introducing into, or we are taking it into a step called extraction of the metal. Now this is in the oxide form. Now I have to extract the metal, then only I can send it for refining. So first is isolation of the ore or separation of the ore. From there I've gone to concentration methods. So in separation of the ore, I took it to the magnetic belt. From there I went to concentration method. In the concentration method, I introduced calcination. In the calcination, some of the vapors, some of the water which is present evaporated. I'm left with iron oxide. Now that iron oxide is taken or it is sent for extraction process. So now we are going to study after that extraction of iron. So for that extraction of iron, so directly the question is given, write the extraction method of iron. You are supposed to write the heading, the table, and that diagram. Okay, diagram also not required, but you should remember the temperatures. Now basically the extraction of iron is done in a long cylindrical blast furnace. Yes, let us see the parts of the blast furnace first. So basically a blast furnace is an arrangement of cup and cone at the top, right? Yes, this blast furnace, what happens, what is the use of this? On the surface of this particular part, we are going to introduce three important things. First, your ore. Which is this ore? Your Fe2O3, which I said, which you are going to purify. This is your ore. Apart from that, I'm going to introduce calcium carbonate. That is your limestone. What is the role of this limestone? Basically, the limestone is used to remove silica or the sand which is there along with your iron ore to form slag. So calcium carbonate, what is the role if they ask you? It is used to remove silica, where I'll show the reactions, in the form of slag. Right, now let us use this. Now coke, I'm also going to introduce coke or carbon. What is the use of carbon? Basically this carbon acts as a reducing agent. The reaction with which your carbon is reducing and forming carbon monoxide, that thing gives you the whole, whatever energy or whatever heat is required in the whole blast furnace, that coke will provide us. So the role of coke is to supply the amount of heat required for all these reactions. Almost it will go above 2000 also. Yes. Now once this particular or this whole thing is fed, let us come back slowly. Once this is fed, there are two. One is your outlet for the exhaust gases, which is present above, and the center at the base you have again one more inlet. This is your outlet and this is your inlet. In the inlet you have a blast of air and oxygen which is sent inside. Okay, now this is called, if I call this part as shaft. Now gradually when I come down, the lower part of the shaft is again divided into 1, 2, 3 and 4 zones. Very important. After these zones, when we come down, right, there are important thing you have to remember. The lower part of the shaft is called Tyrus. What do we call? We call it as TUY Tyrus or Tyrus. So this particular thing, this is where your the blast of air or oxygen which is required enters into the earth, right, or the furnace. Now what happens once we at the lower part of this furnace, you have something, a column called hearth, right? So now at this hearth, at the lower bottom, on one side you have all the solid waste which is collected, and you have your pig iron which is collected on the other side. Okay, now that is the basic idea which you should remember. Now what actually is important, when I take this ore, when I introduce with calcium carbonate and coke, there are different layers, different zones which are formed in the blast furnace. The first zone, thing is I've divided into 4 different zones. The first zone is called zone of reduction. So what did I do? For that particular thing, I made a table, right? Let us write. First, temperature range. What is the temperature range? It is 400 to 700 degrees centigrade. Now what is a zone called? Zone of reduction. Please write it like this only. It is easy for the examiners to correct. Yes. Now second zone ranges from 800 degrees to 1000 degrees. This is called zone of slag formation. Now, this one. 1100 to your 1300 degrees centigrade. This is called zone of fusion. Zone of fusion. After that, above this 1300, that is, it goes up beyond 2000 also. That is, I will write greater than 1300. Right now, where is this occurring above 1300? It is occurring near the hearth, isn't it? Near the hearth. So what is that hearth? The lower part of the blast furnace, hearth. This part is called the hearth. Done. Now let us see the first reaction. First important thing is we are feeding the ore with calcium. We're mixing up with calcium carbonate and coke and introducing into this furnace. Now what happens? The hot air or the blast of air and oxygen is supplied from both the sides into the furnace. So during this process, let us see the reaction. The first important thing in the zone of reduction reaction, as the name suggests, reduction, right? Your iron ore, your Fe2O3, first important thing, is reduced with coke. That is what I said. Correct. So this is going to what happens? Your iron oxide, your iron gets reduced to iron and your carbon gets oxidized to carbon dioxide. Right, let us balance later. Next important, your iron oxide is also reduced with one more reducing agent, that is carbon monoxide. So the same story, iron gets reduced to iron, carbon monoxide gets oxidized to carbon dioxide. So let us balance. If I see, okay, let me put this is 2, okay, this is 3, then this is 4, this also is 3, okay. Then if I balance this reaction, okay, I can write this as 3, okay, yes. Then if I take this as 3, okay, this is 2 because Fe2, yes. Now 3 if I take, okay, this is carbon dioxide. Let us count. Here 2 2s are 4, 4 iron. Here 3 carbons, 3 carbons. Here 3 2s are 6 oxygens, 6 oxygens balanced. In this reaction, 2 iron, 2 iron. Oxygens are 3 plus 3, 6. Here 3 2s are 6. Carbon is 3, here 3. Done. So in your first process, zone of reduction, this is going to happen. So let us write the physical states. Here iron oxide is solid state, right? This is very important. Now coke also is solid state, solid. Yes. Then iron becomes liquid state, this becomes gaseous state or vapor state. Here iron is in liquid state, this becomes your gaseous state. Done. So important thing, what should you write? What is the change occurring here? Iron gets reduced to spongy iron and coke gets oxidized. This is what you have to write, gets oxidized, right? Simple. That's the first zone. After that, when this particular feed enters into this zone, what is this zone? Zone of slag formation. Very important. Now observe carefully. Slag, I said. So what is slag? Your gangue plus flux gives a slag. So now what happens? This carbon dioxide from here, which is here, enters into this zone. Yes. Now this carbon dioxide again combines with your coke. So it's going to form carbon monoxide 2. Very important. This carbon monoxide is acting as a reducing agent. Let us see whether it is balanced. 2 carbon, oxygen 2. This is the most important reaction of the whole furnace. Why? Because this particular reaction is a highly exothermic reaction. Because of this exothermic reaction, the heat which is generated gets transferred to all the zones and allows the other reactions to happen. So remember the important reaction of this zone. Because there's a formation of reducing agent, this reducing agent goes and reduces a metal and finally we get a molten metal. Done. Now after that, now let us see this role. This calcium carbonate, which acts, as I said, it's going to act or it's going to remove the the flux from that particular thing and come out as slag, right? So this calcium carbonate breaks up into calcium oxide plus carbon dioxide. Now this calcium oxide, what does it do? It's going to combine with silica. What is the silica? Your sand or your impurities which is present in the. So this calcium oxide, if I say, this is, suppose if I say this is called as gangue. Gangue is combining with flux and it's going to form a compound called CaSiO3. This is slag. Calcium silicate is a slag, right? So very important thing you have to remember here, calcium carbonate is a highly endothermic reaction, right? It absorbs, as we have seen, the test tube becomes cold. So the amount of calcium carbonate should not be so much in the furnace, right? If the amount of calcium carbonate is more, it tends to reduce the temperatures. Remember that. So we basically, all these are exothermic reactions. This will tend to decrease the temperature. So we add it in limited quantity. So now this has come out as slag. That is going to float when we go down, right? Now what happened here? What should we write? Removal of slag, and what else happened here? Formation of reducing agent which generates the heat. That's done. From here, now I'm coming back to this zone of fusion, right? Here all the things are going to fuse. Now let us see. Now we have our slag which is separated. That's over. Now 4 important reactions you have to write. What is the first important reaction? Your carbon which is there. Here a coke is already there from our visited. Now this oxygen is entering into this zone. This carbon combines with oxygen forming carbon dioxide gas. Right? Now this carbon dioxide gas, what will happen? It will go and it has to escape out. Yes. Now before escaping out, this carbon dioxide gas is going to combine with this coke, CO2 plus coke. What do I get? I'm going to get this. Now there are 2 important gases. Just see, one is carbon dioxide, one is carbon monoxide. Now this carbon dioxide and carbon monoxide, from here they escape out of the furnace. Done. Now during this process, your iron, whatever is there, now your this is there, iron is there, isn't it? But still it is not complete. It's not completely reduced. So your Fe, the leftover iron oxide, how much ever is left out, it's going to be further reduced by coke, and this iron oxide is further reduced by carbon monoxide. So what happens here? I'm going to get now liquid iron, molten iron, and carbon monoxide comes out as carbon monoxide. Here what do we have? Again the liquid iron which we get, and the leftover carbon dioxide gas. Now all our vapors, we are left with molten liquid. Slag is also ready, and your carbon and carbon dioxide and carbon monoxide, they escape out from this particular furnace. Now you have almost, we have come to this part. Just see, 1100 to 1300 degrees. Now everything has fused, correct? Now the leftover iron, a molten liquid or molten iron, just comes down at this particular point. Now this molten liquid or molten, this is called molten slag. Which one? Now this is your molten slag. Just see, this is your molten slag which I have drawn here, and this is your molten liquid or molten metal, which molten iron which I have drawn here. Right? Now here we have 2 outlets. One is out for the solid waste and one for the pig iron. The iron which we obtain here, it is further sent to the refinery where we refine to that particular extent, where we remove all the impurities, and that iron which is extracted out from the furnace is called pig iron. I'll be teaching you what is pig iron and cast iron also. So now pig iron is extracted out, and solid waste, that is your slag, is extracted out from the side. Now, most important thing you have to remember, the slag is lighter than your metal. So, it tries to float above the iron metal and you're separated. Now, what will happen near the earth? Yes, separation of, okay, we have not written this, we'll write separation of solid waste and pig iron. Done. So now here what happened, you have to write this also, isn't it? Fusion. So what happened? It is further reduction of FeO to Fe, liquid, and release of gases. So carbon monoxide and carbon dioxide, they got extracted out. So this is your whole extraction. Start from the ore. send it to the magnetic separator, the magnetic belt, then get it to the concentration process where you may prepare, or you're going to convert Fe2O3 or allow the vapor to escape. That iron oxide, you're going to get it to the blast furnace and show it in the different zones, and finally show the formation of pig iron. This completes your 3 marks if extraction of iron or metallurgy of iron is given to you.